All right, we're going to go through the 4.2 class notes, and I'm going to be talking about our development of the model of the atom and some of the important experiments that led us to that, especially Rutherford's gold foil experiment. So as we look at 4.2, we start to discuss some subatomic particles. The first of the subatomic particles that was discovered by J.J. Thomson, and he discovered the electron by using a cathode ray and determining that the negative pole of a magnet will actually repel these negative particles and the positive pole will attract them. And with that information, J.J. Thomson put forward a model of the atom we call the plum pudding model. He was British, and plum pudding makes more sense to people who are British. For us, we might think of it as like similar to chocolate chip cookie dough, in that you have a positive matrix that would be like the dough, where you have a positive charge kind of spread out, and then stuck within that, he said, might be electrons, and those are a negative charge. So that would be like the chocolate chips and chocolate chip cookie dough. So as Rutherford was doing his experiment that we call the Rutherford gold foil experiment, he was testing J.J. Thomson's model. And so he had certain expectations that if that is true, the true structure of an atom, then certain things would happen with his experiment. So just to recap, and you've watched a really good video already about how this occurred, Rutherford set up an alpha emitter, and the particles, the alpha particles, then were shot at a very thin piece of gold foil, and then you had a detector screen around it. So we shot alpha particles, he shot alpha particles at this gold foil. Alpha particles he knew had a pretty decent mass for a particle and had a positive charge. He expected them to go straight through because that would follow the plum pudding model that J.J. Thomson had put forward. And most of them did. Okay, we'll talk about what that means for our further understanding of structure of the atom. But he was very surprised that some were deflected and changed course rather than going straight through, and some even bounced back. And again, for Rutherford, that was to him the equivalent of shooting a cannonball at a piece of tissue paper and having it bounce back at you. He was absolutely shocked. So let's talk about what this information means, and then I'll talk about what that led Rutherford to conclude for the revision of the atomic model. So the conclusions. First of all, the fact that most of the alpha particles went straight through the gold foil, that led Rutherford to conclude that most of the atom is empty space. So the idea of the atom being empty space overall is contrary to that plum pudding model, which says you've got kind of a glob with electrons stuck in it. And the evidence that most of the atom is empty space is that almost all of the particles, and those are the alpha particles, went straight through the gold foil. And remember, this gold foil is just a few atoms thick. So what they were doing was going through the parts of the foil that had no blockage or nothing to stop them. This is the second part that leads us to his second conclusion, which was especially important here because it allowed him to revise his concept of what an atom is. And that is that Rutherford determined there must be a small and central positively charged part of the atom with almost all of the mass. So he concluded that if these alpha particles were bouncing off of something, it had to be it had to be positively charged because the positive charge of the alpha particles would cause that to deflect and boom, bounce off each other. It had to be very small because this only occurred in like 1 in 8,000 times did it deflect back. It was assumedly central because that would make sense in terms of the electrons. And it had almost all of the mass. It had to be massive in order for these alpha particles to hit and then reverberate back, okay? She named it, that small central positively charged, almost all of the mass part of the atom, he named it the nucleus. So he called this a nucleus, using the term that's used for cells for the central part of a cell. Okay, obviously much, much smaller. We're talking atomic level as opposed to cellular level. So what is the evidence for this? The evidence is that some particles were deflected. The fact that it's only 1 in, say, 8,000 particles means that it's a very small part of the atom. The fact that they were deflected means they had to be the same charge as the alpha particles. And then that it was almost all the mass of the atom means that we have a concentration of that mass in those subatomic particles. So with this information and this discovery of the nucleus, Rutherford is also credited with discovering the proton. He said that these particles that were making up the nucleus had to be positively charged. So Rutherford was describing the proton, which or the symbol, a lowercase p with a plus, so that is the p for proton, and its charge is a plus. Whereas for electron, we use a lowercase e for electron, and then a negative as its charge. Rutherford then came up with what we call the nuclear model for the atom. And he said that it would contain a central nucleus that had a positive charge and contained protons. And he thought that the electrons probably are orbiting this like the planets orbit the sun. So the electrons in orbit. Now, a lot of the graphics that we see for atoms and things look like this nuclear model for the atom, but they are incorrect. You're going to learn more later about our current understanding for the model of the atom, which is actually the quantum mechanical model for the atom. So this was just another progression in our understanding, but this is incorrect. This is not the behavior of electrons. They do not orbit. They do not go around the nucleus like Rutherford postulated. Okay, so that is your information about class notes for this. And for your lesson check, you can look to the next